So quantum computing in 10 minutes and with no math. So I'm going to try to actually keep. I'll have to mention a couple of things about maths, but just literally 2 words, I promise. And the idea here is just to give you the very basic intuition, so you can then take a look at the other videos in the channel and build up further intuition around how to exploit quantum computing features and how to build algorithms on that. So you can take a look at other videos where I break down existing algorithms and I explain how they use exactly properties like entanglement or superposition to do things that you would not be able to do with a classical computer. Essentially, a qubit is different from a bit in that qubit needs to be measured if you want to know whether it's a 0 or a 1. And before it's measured, it can be anything in between. So it can be 20% 0 and 80% 1. And so the way that you represent that mathematically, and that's the only thing that I'm going to mention, is by having an array where you have, the first item is the probability of being 0. In this case, right, when you have 1 qubit, and the second item is the probability of being 1. But you don't have a second item here because it's just 100% 0. And then this number you see here is a number that has a real number and a complex number. And you can operate those two numbers separately, and that's really the magic of quantum computing, so that you can move information inside the qubit in a way that you cannot do with classical bits. And then you can definitely use that to build really amazing and breathtaking algorithms. I'm going to show you now what can you do with a qubit. For example, you can add the X gate. When you run a qubit that's 0 through an X gate, it's going to become a 1. So it's 100% probabilities of measuring 1. Now we see the array has two components, right? So we see that the probability, the certainty in this case, because it's certain to be 1, it's on the real side. You can also do something else. For example, you can use the Y gate, which is going to give you the same result, but the probability, so the certainty in this case, because it's 100% certain to be 1, it's in the complex side of things. When you measure the qubit, it doesn't matter. If you take a look at the measurement probabilities, it's going to be 100% probability to measure 1, but before measuring, you actually, those two things look different, the Y gate or the X gate. So you can use that to your advantage to design algorithms that use those properties and the fact the information is in different spots, to then engineer different outcomes. So this is one interesting thing you can do with qubits. And you also can change the sign of those probabilities, because at the end of the day, it doesn't really matter, because in order to calculate the probabilities, you square them. So, but just forget about that anyway. But you can, for example, when you have a qubit that's 100% has a certain probability of being 1, even if it's 10% or 100%, and you apply a Z gate, that's gonna flip the sign from positive to negative. And you probably can already smell here that if you play with qubits that have a positive certainty and a negative certainty, they might even cancel out. So you see there's something there, right? So feel free to browse around the channel, take a look at other videos where I'm breaking down different algorithms, and you'll see these things in action. And I think it's super insightful to see it from this perspective, and to forget about all the other geometrical and mathematical analogies that you find out there on the internet that explain you about qubits. I think they're useful, but I think they kind of constrain your thinking a bit in the beginning. So because they bind you to a visual representation in 3 dimensions that can be a bit confusing sometimes when you add more qubits into the picture. Because the thing is, when we now add another qubit, or let's exactly another qubit, then you have, like, of course, now you have 0 0, right? But you can one thing you can do with quantum computing or quantum programming is you can create uncertainty, and you can create uncertainty with a gate like the Hadamard gate. You can do this with other gates, but the Hadamard gate creates uncertainty. Basically, when you use it, it's just with 2 qubits, you can represent all the possible combinations with equal probability. So you have equal probability of measuring 0 0 0 1 1 1 0 or 1 1. That is another interesting feature, right? Because basically what you can do now is you can encode information here. So you see that you have that, right? But you can maybe decide now that you want to flip one sign. So you're gonna, for example, do a Z here. So now you're gonna have two of those numbers are gonna be minus. And on top of that, if what you now do is, like, I don't know, you apply a next gate, then you move them completely to the other side, right? So because what you're doing is you're playing with this information, so that really gives you endless possibilities to be. The thing is, it takes a while until you figure out how to use those things. So browse the channel, take a look at other videos, and let me know how you like it. So this is one thing you can do. You can also create correlations in quantum computing. For example, if we stay at this state, right? So, and we have a Hadamard here. So basically, this is a 0, so we're only going to measure 0, 1, or 0, 0, 0, 1. But now we can apply control X. What the control X does is it applies an X to the second qubit only if the first qubit is 1. But the first qubit is in superposition, so it's uncertain, right? It can be a 0 or 1. So you're kind of creating a state in a way you can now measure only 0, 0 or 1, 1. So they will always agree. And that has like major implications for, what can you build with that from, communication protocols to different fancy stuff in cryptography. Really, really, really interesting thing. So, and that's basically it. I mean, those are the three essential things: the dimensionality of a qubit, entanglement, which is what we see here, and superposition, which basically means that you can represent multiple different possible states at once. And you can play with other gates in here. You kind of have rotations, you have different fancy stuff. You can swap the qubits. You can build a lot of interesting things. So this is just to give you a 10-minute primer with no math. Other than how you represent that, right? So you can see here the information where it's being put, and how you can flip it around and stuff like that. Another important property before we finish the 10 minutes is that you the operations you make, you can also undo. So especially when it comes to certainty and uncertainty. So you can, if we now are adding uncertainty, if I were to add the same gates again, I would be removing that uncertainty and going back to my certain state initial 0, 0. But if I mess up with stuff in between, then guess what's going to happen? Something really interesting. Say you add 3 qubits, right? Now you're going to see some interesting stuff, because now we can also get into a superposition state, for example. And if we apply the following combination of gates, it's going to help us flag 111 with like with a negative certainty. So if we're doing it this way, and I'm just like, I know this is a construct that helps us do that. So whenever you have this now, and you're going to see that if we now try to undo that, and try to go back to our previous certain state, which was 0, 0, 0, we are not going to be able to do that anymore, because we've added that negativity in here. So and when we when we now apply, for example, so we apply Hadamards again. Let me apply, this is just, just to make the circuit nice and readable. If I now do this, and I do this, and I do this, then we end up with a state where, look, the 0, 0, 0 is kind of, you're almost going to get it, but you're still going to have a bunch of probabilities that are spread across the other states. And so this kind of, this tells you how mind-blowing this is. The more qubits you add, the more interesting things you can say. So, play around with the videos that you have in the channel, and if there's any interesting topics that you'd like me to explore, put a comment, and or take a look at my Twitter, Quantum Intuition, or Learn Quantum is the Twitter handle, and I'll take a look at your requests. Have fun, and let me know how you like it.